Leningrad, 1957. An engineer named L.S. Troyanov sits down with a set of requirements that nobody in the history of armoured vehicle design has ever tried to meet before. The brief comes from the Soviet military's main armour directorate. It follows a decree of the Council of Ministers issued in August of 1955. The Soviet Union wants a new heavy tank, but not a tank in the conventional sense. The requirement is more specific than that. The tank must be able to fight on a nuclear battlefield, not near one, not after one. On one, the brief assumes that tactical nuclear weapons will be detonated over the European battlefield while armoured vehicles are still in operation. The vehicle being designed must be able to advance through terrain devastated by those detonations. It must be able to cross ground churned into craters. It must be able to cross ground turned to liquid mud by the overpressure wave. It must be protected against radiation, against heat, against the shaped charge weapons that are rapidly becoming the standard anti-tank munition of every army in NATO, and most specifically, it must not be flipped upside down by the shockwave of an atomic bomb. This is not a theoretical requirement. Soviet military planners in the late 1950s operate under a doctrine that assumes the next war in Europe will involve tactical nuclear detonations on the battlefield itself. Both superpowers have hydrogen bombs. Both are developing smaller nuclear weapons specifically designed for battlefield use. American nuclear artillery has been deployed to West Germany. Soviet doctrine calls for breakthrough attacks into Western Europe across terrain that may have been hit with nuclear weapons minutes before the tanks arrive. A conventional tank hit by the overpressure wave from a nearby nuclear detonation will be lifted off the ground and overturned. A 60-ton vehicle becomes a 60-ton projectile. The crew inside survives the blast only to be killed when the vehicle lands upside down. Troyanov's job is to build a tank that stays on the ground. The solution he designs over the next 2 years is unlike anything that has preceded it. It sits in the Kubinka Tank Museum outside Moscow today, where visitors who see it for the first time consistently describe the same reaction. They stop, they look again, they try to understand what they are seeing. What they are seeing is a vehicle that appears to belong to a different era entirely, not the future. Something stranger than that. The hull of Object 279 is not rectangular like every other tank in every other army in the world. It is elliptical, oval in cross-section, rounded at the top and bottom, the curves flowing continuously from the front to the sides to the rear. The result is a shape that looks less like a military vehicle and more like something that should be in orbit. Soviet engineers who worked on the program had a simpler description. They called it the flying saucer. This geometry was not aesthetic, it was physics. A nuclear shockwave is a pressure wave moving through the air at supersonic speed. When that wave hits a flat vertical surface, like the side of a conventional tank, the pressure acts on the full area of that surface simultaneously. The force is concentrated, it can push the vehicle sideways. If the vehicle is hit from the front, the wave can lift the front end and tip the vehicle backward. If hit from the side, the wave can roll it entirely. A curved surface behaves differently. When the pressure wave reaches the elliptical hull of Object 279, the curvature redirects the wave around the vehicle rather than concentrating force on it. The wave flows over and around the hull the same way water flows around a stone in a river. The direct force on the structure is reduced. The vehicle does not lift, it stays on the ground. This was not the only function of the elliptical shape. The outer panels of the hull, the curved plates that give it its distinctive appearance, are mounted at a distance from the actual armour underneath. They are spaced armour against shaped charge rounds. When a rocket-propelled grenade or a missile warhead detonates against spaced armour, the shaped charge jet disperses before it reaches the main armour beneath. The outer panels take the detonation. The main armour survives intact. The crew inside the inner hull is protected by both layers. The main armour itself was extraordinary by the standards of 1959. The turret front measured 319 mm of cast steel. The hull front measured 269 mm at its thickest point. These figures are not comparable to anything else in service at the time. For reference, the turret armour of the Object 279 was significantly thicker than the turret armour of the T-72, a tank that would not enter service until the 1970s. Engineers achieving that level of protection in a prototype completed in 1959 were working at the absolute frontier of what Soviet industry could produce. The problem that armor of this thickness creates is weight. Object 279 weighs 60 tons. A standard medium tank of the same era weighs between 30 and 40. A vehicle of 60 tons pressing down on two conventional tracks creates ground pressure that makes swampy or soft terrain impassable. The vehicle sinks. It cannot advance. Troyanov solved this with the most visually distinctive feature of the design. 4 tracks, not 2, one on each side of the hull. 4, 2 on each side, arranged in pairs, each pair mounted on a hollow longitudinal beam running the length of the vehicle. The beams themselves serve a dual function. They are structural members of the hull. They are also fuel tanks. The 4 tracks distribute the 60-ton weight of the vehicle over a contact area, roughly twice that of a conventional 2-track design. The result is a ground pressure of 0.6 kilograms per square centimeter. That figure requires context. A vehicle of 60 tons achieving a ground pressure of 0.6 kilograms per square centimeter is producing the same pressure on the ground as vehicles that weigh far less. The 4-track system allows Object 279 to cross terrain that would stop conventional heavy tanks entirely: soft ground, marshland, the churned crater fields that would exist after a nuclear detonation. Ground that a 2-track vehicle of comparable weight would simply sink into and stop. The suspension between the tracks and the hull is hydropneumatic, adjustable in ride height by up to 500 millimeters. The crew can raise or lower the hull relative to the ground depending on the terrain being crossed. On flat ground, the hull sits low, reducing the silhouette the vehicle presents to enemy fire. In broken terrain, the hull rises, giving the tracks clearance over obstacles. The engine driving all of this is a 2DG8M diesel producing 1,000 horsepower. For a 60-ton vehicle, this is sufficient to reach a road speed of 55 km per hour and an operational range of 300 km before refueling. The fuel carried in the hollow pontoon beams beneath the tracks contributes to that range without requiring additional external fuel tanks that would add to the vehicle's profile. The main gun is a 130mm M65 rifled cannon with a barrel length of 60 calibers. The caliber is significant. Standard Soviet medium tanks of the era were armed with 100mm guns. The Object 279's 130mm gun generates considerably higher chamber pressure and muzzle velocity. At combat ranges, it can penetrate any armor then in service with any NATO country. The loading is semi-automatic, achieving a rate of fire of 5 to 7 rounds per minute. The ammunition supply is 24 rounds. Secondary armament is a 14.5mm heavy machine gun mounted coaxially in the turret. The same caliber used in Soviet heavy machine gun emplacements, capable of penetrating light armored vehicles and stopping infantry at long range. The crew numbers 4: commander, gunner, driver, and loader. All 4 sit inside an inner hull that is sealed against chemical, biological, radiological, and nuclear contamination. An overpressure system prevents outside air from entering. A heating and cooling system maintains temperature in the crew compartment. An automatic fire suppression system operates in both the engine compartment and the fighting compartment. The crew of Object 279, in theory, could survive environments that would kill any crew in any other vehicle on the nuclear battlefield the Soviet military was planning to fight. If you are finding this examination of Soviet weapons engineering of interest, subscribing to the channel helps ensure you do not miss the next one. The trials of Object 279 took place in 1959. The results were not straightforward. Across firm ground and moderate terrain, the vehicle performed as designed. The 4-track system delivered the ground pressure figures that Troyanov had calculated. The hydropneumatic suspension operated correctly. The vehicle was stable at road speed and handled the cross-country course without difficulty. The problems appeared in the terrain Object 279 had been specifically designed to cross. On very soft or boggy ground, the 4-track system became unpredictable. The 2 pairs of tracks on each side could flex independently of each other as the ground beneath them varied. This flexibility, which was an engineering feature, became a liability on certain soil conditions. The vehicle became sluggish to steer. The driver had less direct control of the vehicle's direction than in a conventional 2-track design. In conditions that approached the worst-case nuclear battlefield terrain the vehicle was intended for, it was harder to drive than expected. The complexity of the four-track system created a second problem. Repairing it in the field required technical knowledge and specialized equipment that a frontline maintenance crew would not have available after a nuclear exchange. A conventional two-track vehicle could be partially repaired by its crew. Object 279, if a component of the track system failed in combat, would require a level of engineering support that combat conditions would make impossible to deliver. The interior was cramped. 60 tons of armor, mechanical components, fuel systems, and crew protection had to fit within a hull that the elliptical shape constrained in every dimension. The 4 crew members worked in conditions that existing Soviet tank doctrine had not accounted for. Extended operation inside the sealed NBC environment that made the vehicle survivable on a nuclear battlefield was physically and psychologically demanding in ways the trials exposed. None of these problems were unsolvable in principle. They were engineering challenges that additional development time and resources could have addressed. Object 279 was a prototype, not a production vehicle. Prototypes have problems. The purpose of trials is to find them. But the trials of Object 279 did not lead to a development program. They led to a filing cabinet. On July 22, 1960, Nikita Khrushchev attended a demonstration of new military technology at the Kapustin Yar test range. He watched the equipment on display and gave an order that ended Object 279's existence as a program before it had produced a second prototype. No tank weighing more than 37 tons would be approved for military adoption. Object 279 weighs 60 tons. Khrushchev's reasoning was not arbitrary. He had been watching the development of anti-tank guided missiles since the mid-1950s and had reached a conclusion that tank designers across the Soviet military disputed but could not effectively counter missiles, he believed, had made the heavy tank obsolete. A guided missile could be fired from a vehicle that weighed a fraction of Object 279. It could penetrate armor that no tank of any weight could adequately protect against. The resources required to build one Object 279 could build several lighter, faster vehicles that could each carry a missile launcher. He was not entirely wrong. Anti-tank guided missiles had fundamentally changed the mathematics of armor protection. No thickness of steel was immune to a shaped charge warhead delivered with precision at extended range. The idea that a tank could be built heavy enough to be invulnerable was becoming increasingly theoretical. But Khrushchev's decree did not distinguish between the Object 279 and the conventional heavy tanks he rightly saw as obsolete. It eliminated the entire category. Object 279 was a vehicle designed for a specific problem that no other tank in any country's inventory had attempted to address: the problem of the nuclear battlefield. The problem of shockwave survival, the problem of crossing terrain that a nuclear detonation had made impassable to every other vehicle. That problem did not go away because Khrushchev issued a decree. The Soviet military's doctrine of breakthrough attacks across potentially irradiated European terrain remained in place for decades. The requirement that had produced Object 279 remained valid. There was simply no longer a vehicle that could meet it. The prototype completed in 1959 was placed in storage. The program was officially terminated on July 22, 1960, the same day as Khrushchev's decree. The team at the Kirov plant in Leningrad dispersed to other projects. The drawings were filed. The vehicle sat in a closed facility for years before eventually being transferred to the collection at Kubinka. There is some ambiguity in the historical record about how many vehicles were completed. Most sources state one prototype. Some indicate that a small number of additional vehicles in various stages of completion existed when the program was cancelled. If they did, they have not been located or publicly identified. The vehicle at Kubinka is the only confirmed surviving example of the Object 279 anywhere in the world. It sits in a hall at the Kubinka Tank Museum alongside other experimental Soviet designs that never reached production. The visitors who stop and look at it are not looking at a failed prototype in the conventional sense. They are looking at an answer to a question that the people who built it believed was real and urgent. What does a tank look like if you design it to survive a nuclear war? The answer is 60 tons of cast steel in an elliptical hull, 4 tracks distributing the weight over ground pressure equivalent to a much lighter vehicle, armour thicker than anything that would enter service for another 2 decades, a gun capable of destroying any armour then in existence, a sealed crew compartment with NBC protection and temperature control, and a shape that looks like nothing else in the history of armoured vehicle design. It was designed to drive through a nuclear explosion and come out the other side fighting. The war it was built for never happened. The doctrine that created it was revised and then revised again as the nuclear calculus shifted through the 1960s and 1970s. By the time the Soviet Union collapsed in 1991, the idea of armoured breakthrough attacks across a nuclear irradiated European battlefield had been abandoned as a planning concept by both sides. Object 279 was made obsolete by a war that never started, and a decree from a man who would himself be deposed in 4 years. It sits in its museum now, exactly as strange as it was the day it left the Kirov plant.